Hello everyone, welcome to all on my YouTube channel, and we'll have the next video lecture series on basics of Python, and we are going to start today with literals in Python. So we'll have an introduction on related to the Python, and then we are going to see which are the different literals that are available in a Python. So everyone knows right now the Python is very popular language, and it is an object oriented very high level language, and which is used for the multi-purpose in our programming language. So now where we have these applications of Python, or where we are using the Python, so it is used for the various usage in web development, then software development, as well in machine learning, data science, data analysis is there, in mathematics, as well as in game development and different desktop applications. So these are some various usage of our Python language nowadays. And now we are moving towards the basic concept in a Python, which is nothing but the literals in a Python. So what exactly the literals? Literals are nothing but whatever the value we are assigning to the variables that we are calling it as a literals. So these literals are defined as a raw data that is given in a variable constant. So we are assigning some values to the variables, and that values are called here as a literals. So in Python we have a different literals string literals are there, numeric literals are there, Boolean literals are there, special literals, as well as the collection literals. So we are going to see these different literals in Python in detail in further slides. So let's start with what are the different examples of literals are coming under these different categories. So these are the things that comes under the literals. So there are the 5 broad categories of literals, like a Boolean, we have a numeric, string, special, and the collection. Where if we talk about the Boolean literals, so which kind of values we can assign to variables when we are talking about the Boolean literals. So here it comes true and false like value. They are coming under the Boolean literals. If we assign some values like integer, float, complex number, any octal number, hexadecimal numeric system, so that comes under the category of numeric literals. If we are assigning some single line strings or the multi-line string to one kind of variable, then that is called as a string literals values. Then one more special literals we have in a Python, which is called as a none. So none is a keyword which is given to any variable without any quotes, where we are using the quotes for the strings, but here the none is only the single special literals available which can be assigned to any of variable. Then comes the collection literals. So there are the multiple types like a list, tuple, dictionary, and the sets. So these all are called as a collection literals, where we have the collection of different data types like we can have integer, float, then Boolean, as well as the string, special. So all can be get collected together, and therefore they are called as a list collection literals. And examples are here the list, tuple, dictionary, and sets. So let's move ahead and we'll see one by one the different literals over here. Then coming with a string literals. What is exactly the string literals? When we are assigning some values in the form of characters or a string to any kind of variable, then it becomes the string literals. But this string literals are always taken in the form of quotes, means the strings are always represented in Python in the form of quotes. So that quotes can be a single quote, it can be a double, it can be the triple quotes while representing the string. A character literal is a single character surrounded by single or double quotes. If we want to say we are assigning some single character to any variable, so it data types becomes the string, means the single character is also treated as a string in Python. Whereas in C or C++ we have one data type called as a character to assign the single character, but this is not the case in Python. It is again treated as a string itself. So here are some examples that we can see in front of you right now. There are the 3 examples are given. One is given within a single quotes, where we are giving some string like single quote string that is mentioned within a single quote. Then comes the example 2, where we are representing one string like double quote string, which is given in a double quotes, and we can also make a use of triple quotes to represent the string, and here we are representing the string triple quote string in a triple quotes. So these are the ways that we can define a string within a Python, and whatever we can see right now on this right hand side, these are called as a literals. So single quote string is a string literal, double quote string is also a string literal, and the triple quote string is also a string literal. So these are the literals, and what kind of values or what kind of literals we are assigning to the variable, that becomes the data type of variable in Python only. Now moving forward, there are the two types of the strings supported in Python. So in the previous slide we have seen that in a strings we have a single line and multi-line. So that is what again we are going to see here, what is the single line string and what is the multi-line string. So in a single line, again the things are repeated when we are mentioning a strings within a one line only. In a single line only, we are calling them as a single line strings. And if we have the multiple line string over there, means when we have to represent a paragraph or any para for the different things, so over there we have the multiple lines, and that multiple lines can also be treated as a string literal if and only if we are mentioning them within a triple quotes. So we can see here the triple quotes are used, so they are representing the multi-line. So in a first line we have ABC, and in the next line we have a character Z. So there are the two lines, and the two line strings are shown here by the triple quotes, which are treated as a multi-line string over here. So this is all we have for the string literals. Then if we want to represent a multi-line string, so is it a triple quotes only the way to represent? No, actually there are the four ways to represent the multi-line string within a Python, and what are that we are going to see right now. So adding the backslash at the end of each line can also represents a multi-line string. So here is the example. If we have the string, this is an example of multi-line string using a backslash. So you can see this statement that whatever I have read right now, that is divided into three different lines, right? So we have the three different lines, and if we want to represent them, then we are representing that by using a backslash. So this is this is given in double quotes, which are given with this backslash, means we have to write now on the next line. Example of multi-line string, again given in the form of the string, again comes the backslash, means again the next line is there, and then using a backslash. So here we are not providing the backslash because there is nothing in the next line, so no need to write here. So every string on every line is given in the form of quotes and then followed by backslash, except the last line, right? Now this can also act as a multi-line string here in a Python. The using triple quotes, again same thing is repeated, that the triple quotes can also be used to give the multi-line string literals here, and no need to make a use of backslash over here. Next come, we can also make a use of brackets to show the multi-line strings. So here instead of using slash, represent that within the bracket. The rest of things are same, means on every line you have to write down the string within the quotes only. You have to make a use of quotes. That quotes will be double quotes or single quotes, and then all lines or that multi-lines statements or strings, they should be taken in a parenthesis. So this is also a representation of a multi-line string. We can represent likewise. No need of comma, no need of a backslash, nothing else. Simply we are writing every string on each new line within a quote only. And one more is there, that is what the multi-line string using a join. So the string is the concept where we can have an operation called as a join operation. So what exactly join says? It is going to join all of the strings which are there represented on a different lines, and they are get joined over here with empty space. So here we are not giving anything, means empty space. So this strings will get joined here by an empty space. This is what the way to represent the multi-line strings. So this is all about the string literals. Now we are moving ahead for the next literals in a Python, and that is nothing but the numeric literals. So everyone knows we have the different ways of representation of numeric number. We can represent the whole number, real numbers. We also have the representation of complex number, floating point number, that is the with the decimal value. So different ways are there. We also have the hexadecimal representation, octal representation of number. So everything is related to the number system. We can represent by using the numeric literals in a Python. The numeric literals are immutable. The thing is given is very important. Here they are immutable, means we cannot change that numbers once assigned. Okay, so they are immutable type, means you cannot change them. Now what are the different numeric literals? So very first comes the integers. Int is a word that we are using in a Python, and its meaning is nothing but integers. So what exactly the integers? So the numbers that can be both positive as well as the negative with no fractional part. So no pointer value should be there, no fractional part should be there. That values are completely treated as a integer value. So example is given as a 5,000. So if we represent the 5,000 with no fractional part, so simply it is treated as a integer literal, numeric literal as a integer. Then comes the next as a long integers. So integers of unlimited size which are followed by a lowercase or uppercase character L, that is stands for the long. So here we can see a number is followed by L as a lowercase or uppercase character. So this is treated as a long in Python, which is the long literal or a numeric literal long in a Python. Then comes the floating point. When we have some fractional part with a number, decimal part with a number, then we have to treat that as a floating point. So here a real number with both integer and the fractional part as a treated a floating point number. Simply we can see here 30.56 which have a real part, integer part and the fractional part. So we can treat it as a floating point number. One more concept is there, that is called as a complex number. So everyone know that when we have the real and imaginary part of any number system, so we simply call them as a complex number. So here 5 is nothing but the real part, where the 3.14j is an imaginary part of this complex number. So we can also have this numbering system under the numeric literals, which is called as a complex over here. So if we talk about the examples, so you can see the many examples are here right now in front of you. So if we say C is equal to 23, so simply it doesn't have any floating point values, so we can call it as an integer literal. And D is having some octal values, and E is having a floating point values. F variable have the value which is in the form of complex number, and G is having the values in the form of the hexadecimal number. So these are the values that we have assigned to some of the variable called as a C, D, E, F and G. So which values we have assigned? We are assigning here. So the integer value, octal, floating point, complex number and hexadecimal. And after that, if you're going to see that what exactly the value of C, if you try to print that C, D, E, F and G, then you will come to know what exactly is printing. So value of C is printed as a 23, which is the integer literal you have assigned to the variable C. Then 175 is a value which is the octal literal value, and which is converted while printing we are printing D. So this octal value is converted into 175 and printed. Then when we have an floating literal, so it is printed as it is. Then when we have a complex literal, and if we want to represent their values as an f dot real and f dot imaginary, means we want to access their real part and imaginary part separately. So you can see that 23 is represented as a 23.0, means in the form of float, and 5j is what your imaginary part, where if we want to access the imaginary part of that f variable, so 5.0 is taken, that is again a floating point value is printed. And if we want to say that value of G, if we want to print it, so hexadecimal value, hexadecimal literal is provided to the G, and while we are printing them, so we are printing it like 397, so which is the value, integer value of that hexadecimal number. So this is all about the numeric literal. Now coming forward toward the next literal, that is a Boolean literal. So everyone knows that the Boolean have the two values, true or false, positive or negative, yes or no, 0 and 1, right? So these are the values to the Boolean. So here the Boolean literal have two values, either true or a false. So if we say A is equal to true and B is equal to false, and if we try to print that A plus B, so A stands for the true, B stands for the false. True stands as a 1, false means 0. Okay, so if we are taking A plus B, means what we are doing, 1 plus 0. So 1 plus 0 becomes 1. So while printing A plus B, you can see here it is printed as a 1. Why? Because true stands as a 1, true means 1, false means 0, 1 plus 0 becomes 1, and here it is 1. But if you want to print that 1 plus 0 in the form of Boolean only, means in the terms of true and false, so simply you need to do the typecasting, means convert that answer A plus B, that is 1 plus 0, whatever the answer is there, print that in the form of Boolean only. So 1 plus 0 is 1, 1 is nothing but true, so the Boolean form of true, 1 is nothing but true, and that is what printed over here. So A plus B simply give you the answer in the form of 1 and 0. If you want to print it in terms of true and false, so you need to make a typecasting here, need to convert it into Boolean. So this is all about the Boolean literals we have. Then comes the special literals. What is the special literals in a Python? So actually we have seen the example of the special literal previously, that is nothing but the none. So none is only the value that can be assigned to the variables without any quotes provided. So no need to quotes, as it is a string. None is nothing but the string. But in Python, it is acting as a special literals, means a one kind of special value that can be assigned to any variable over here, and that value none is used to specify to that field that is not created. It is used for end of the list in a Python, means any field is not created, we can simply assign a null, which is the special literal in a Python, only single special literal. So we can see the example here. If we are assigning the value 10 to the variable val1, if we are assigning the value none to the variable val2, now you can see the difference. Strings are always given in the quotes, where the none is given without quotes, because that is the special literals in a Python. So if we try to print the val1 and val2, so val1 is having the value 10, that variable is printed with the value 10, where the val2 is get assigned with the none, and we are printing the none here for the val2. If you try to print that val2 with any another like a string without any quotes, like if I say val2 is equal to abc without any quotes, if I trying to print that val2, if we are not providing any quotes to abc while assigning the value value to the val2, and if we try to print, it will generate error, because abc is not any special literals that you cannot assign without quotes. That can be act as a string only if we are providing within a quotes. So this is all about the special literal. A single literal is there, that is called as a none. And the last one is the collection literals, which is a very important part of this Python. So actually there are the 4 types of literal collections are provided, like a list literal, tuple literals, dictionary literals, and the set literals. So we are going to see it one by one. So what is the list literal? List contains the items of different data types, means we can store the different data types at the same time within a list. Lists are called as a mutable, means they can be modified, they can be changed, we can alter the elements of the list, and that's why they are coming under the category of mutable data type or a mutable literals. The values stored in a list are separated by comma, and they are enclosed within the square bracket. So every time when we are going to define the list, we have to make a use of square brackets, and every value will be separated by comma. We can store the different data types of the data, different types of data within a list. Like in a list, we can store integer, at the same time we can have a float, we can have a string, we can have another list, we can have the tuple inside it. So nested list concept is also there. Now for example, here it is given the list which have John, which is in the form of string. We have 6, 7, 8, which is a numeric literal and integers specifically. 20.4 is again the numeric literal but floating point. and the Peter is again a string which is given in a quotes. So two strings literals are there, two string values are there, and we have the next as a integer, and we have a floating point. Again another list one we have created where 456 is one integer and Andrew is another string given here. If we try to print the list, means a list that is what having a John 6, 7, 8, 20.4 and Peter. So if we print, so we can see that it is printed like this. So in the form of list, which is within a square brackets, every value separated by comma. And if we try to concatenate the two list, so plus stands here only for the concatenation of the list. So if we concatenate this list, so the list one is get concatenated in a list only. So list first come and then elements of the list one will come. So John 6, 7, 8, 20.4 Peter, these are the elements of the list, and then we have to concatenate the elements of list one in a list. So then followed by 4, 5, 6 and Andrew. So this is the way we can have the concatenation of two lists as well. Then comes the dictionary. Dictionary in a Python have the storage of values in terms of the key value pair. So here we can store the data in terms of the key value pair. Here it is mentioned. It is enclosed by a curly bracket and each pair is separated by comma. Again the thing is same, that we have to separate the values by the commas, but only the thing is they should be get mentioned within a curly brackets only. So here is an example. We have a dictionary, and here we are representing the dictionary having the key value pair. So key is name, its value is Peter. The age is again the key, its value is 18. The roll number is again the key, its value is 101. So keys are name, age, roll number, where our values are Peter, 18 and 101. So if we try to print this dictionary, then how it will get printed? We can see right now in front of you. The result is there, output is there, and within a curly bracket we are printing the name as a key and Peter, then age as a key and 18, roll number as a key, then 101. We are representing the keys here in the terms of quotes because they are of the form string. If the keys are in the form of numeric or a floating point, no need to represent them in the in quotes, in any kind of quotes. So simply we can say 1 is equal to any string or value, then 2 colon any string value, whatever integer is there. So keys can be a string, keys can be an integer. If they are integer, no need to represent them in a quotes. If they are in a form of string, then there is a need to represent them in a quotes. So this is what an example of a dictionary collection literals. Then moving forward towards the tuple. This is also have the collection of different data types, but they are coming under the category of immutable data type. Means we cannot change, we cannot alter any elements, or we cannot modify any part of the tuple. So while we are writing the different data types within a tuple, every value will be separated by comma and they should be get represented in a parenthesis. So these are the parentheses that we have to use. The rounded bracket should be get used while representing the tuple, while declaring the tuple. So here we can see tuple is created. Tup is the name of a variable, and we are assigning the value 10, 20, then one string dev, and again we have a list. So this is what another collection literal we are assigning as a value in a tuple. So within a tuple we can have a list, within a tuple we can have another tuple, within a tuple we can have a set, within a tuple we can have the dictionary, different data types collection we can store. So when we are assigning the value in terms of tuple collection literal, so the type of variable tup becomes the tuple. So generally what happens in C and C++, when we are using any kind of variable, initially we have to declare the type of variable, that which kind of value that variable can accept. But here in Python this is not the case. Whatever we are assigning as an literal to that variable, that becomes the type of variable. So here right now in rounded bracket different values are separated by comma. So this is the representation of tuple. So therefore the tup is the variable which data type becomes the tuple, which is the collection literal. So if we try to print this tuple, then we can see every value is separated by comma, which is printed within the a curly bracket or a parenthesis, we can say. So here is one small program we can see in front of right now. What exactly it says? That we have a tuple 1 which contains tea, coffee, juice. These are the 3 different strings within a tuple. If we are printing tuple 0, means at 0th position there is a tea, so that's why it is printing tea. At then first position there is a value coffee, then it is printing the coffee. So likewise we have the indexing to the tuple as well. So at 0th index t is there, so we can access that tuple of 0 is nothing but value t. At tuple of 1, what is the value? Coffee. At tuple of 2, what is the value? Juice. So this is the way we are providing something. Also the negative indexes are available. 0, 1, 2 are the positive index, means we can starting the index from left to right. If we try to give it the indexing from right to left, so it can be accessed like -1, -2, -3 onwards. So we can start accessing the elements from ending as well. So that facility is also there for list tuple here. So here is an example given. If we say that the tuple 1 of -1, if you want to access, so at -1 juice is there, at -2 coffee is there, at -3 tea is there. So this is the way we can access the elements from backend also. So this is all about a tuple, and the last collection literals is nothing but set. What is the set? Python set is the collection of unordered data set. This what is very important, that is what the unordered. So everything in that set is always in an order format, which is not in the fixed order format. Again, it is enclosed in curly bracket, the same like a dictionary. Dictionary also stored in a curly bracket, but over there we have the key value pair. Here is no concept of key value pair. Simply we have to store the values with the different types, and each element is again separated by comma. So here is one example in front of you right now. Apple, grapes, guava, papaya, these are the name of fruits which are acting as a strings, which are provided in a set format. And now if we try to print, we can see whatever we have provided, like apple, grapes, guava, papaya. Now their order is get changed. So whenever you are printing the sets, every time it will show you the different order. And one more highlighted property is that they avoids the repetition, which is what the basic concept of sets from the mathematics, right? In mathematics, what is the set? So it avoids the duplication. The repeated elements are taken only once. The same thing is here. If we have apple double, then it will print it only once, right? So repetitions are avoided. And the second thing, they are always printing the sets in the form of unordered data set. So they are not in a order. Right now they are showing guava, apple, papaya and grapes. Again, if we try to run this print set statement, again it will print it in the different order. So that's why it is called as an unordered set, which is only applicable for the set collection, not for any other data types. For other collection like dictionary, list and tuple, whatever you are giving in with whatever the sequence you are giving, in that sequence only it is get printed. But this is not the case in a set. So this is what somewhat different collection literal compared if we are going to compare it with the list, tuple and the dictionary. So this is all about the collection literals that we have completed and finished with the topic called as a literals in Python. I hope you like this contents. Thank you so much. Thank you all of you.